Sure, I'm Zachary Hunter. I work with Steve Treon at the Bing Center for Waldenstrom's Macroglobulinemia at the Dana-Farber Cancer Institute. I've been working at Dana-Farber for the last almost 12 years. As hard as that is to believe. I started actually not aiming to go into medicine, but actually applied math. My undergraduate degree was in mathematics, and I bumped into Steve, and I had worked in biology. Actually, I'd worked at Harvard as a researcher as young as in high school, and I had gotten to college and had sort of grown disenchanted with biology. And Steve gave me the opportunity to try it again for a year. He said, just give me a year, get me through this one conference, and then, if you want to go to grad school, go for it. And I loved it. I just loved it, and I never looked back. And it's been an amazing experience being able to do science, come in every day, and know that the work that we're doing is directly helping people, and people who I know and who I've met and I've got to know over these years. And that these findings, what we're doing is actually leading to real changes in patient care, things that we can point to. And I think I can speak for everybody who I work with that we're really excited to go in every day for that reason. It keeps us motivated. It's what we're there for. It's been a blessing. So with my math background, I naturally became the big data guy. Whenever people had an analytical problem they couldn't solve or they're having a difficult time with, all of a sudden it would wind up on my desk. And over time, that has led me to work on inheritance and familial Waldenstroms, but primarily with sequencing studies, looking at what it is that makes Waldenstroms tick. The genetic changes in transcription, at the protein level, and trying to paint the big picture. Because if we can understand the biology, that means we can develop new treatments that are specific to Waldenstroms, not treatments that target all the cells in your body, but really just go after the cells that we want to go after. And this has been an incredible opportunity, really amazing resource. We actually now have, just on Waldenstroms, we've generated probably over 50 terabytes of data that we go through and we try to make sense of, and we sit in lab meetings every week trying to be like, well, what do you think about this? Or look at it a different way. It's been very inspiring. When I first started working on Waldenstroms, I'd never heard of it, like many people. But one of the things that was amazing to me is, as I started to talk about my work, I actually found I had a number of very personal connections to this disease. My aunt's family has familial Waldenstroms. A number of close family friends actually turned out to have this disease, and it's quickly become something that I knew nothing about, to being something that is now quite personal to me. So this is a really exciting time to be in research. Things are opening up. There are now things that we can do that we couldn't have even dreamed of just a few years ago. We can sequence entire genomes, look at protein phosphorylation in ways that, again, sort of bend the mind. And it means that there is just incredible opportunity, things to discover, and real differences you can make. You can look back over your year and say, you know what, I actually changed the course of research. And this is true in a way that in which it really hasn't been for quite some time. Science moves in fits and spurts, and right now we're really in a spurt. Things are really growing and changing, and it's a great time to be involved. And Waldenstroms in particular is an amazing disease to work on. It's incredibly complicated, it's very rewarding, and again, there's a lot of progress that is being made and that can still be made.